Hey, hi, hello, welcome back to my YouTube channel Andrew Or, where we simplify complex fact into simple and understandable facts. Today we are going to start another series on SQL Alchemy, where we are going to learn the basics of SQL Alchemy and how we can use in a production application. So we are more concentrated on fast API kind of template here, and uh, we are going from the absolute basics to how you can implement SQL Alchemy in a production application. So don't waste our time. Let's get started. Okay, so for our practice, I'm just creating another project in Python where we are going to implement and discuss about database engines today. And I'm using a UV as my environment manager here. If you want a video about how you can manage install and manage UV, I can do that as well. Please feel a comment on this video. And we have other options also, poetry and VNV based environments. Uh, we can go with any of them as you wish. It's up to you which environment you need to use. So I always recommend UV because it was fast and reliable option. So let's get started. Uh, I'm going to create a README file so we can write it as well. Going to first, we need to answer what is an engine? Database engine means. That's the first question we are going to answer first. Database engine is where we are going to set up the connection. So we can say in SQL Alchemy, which is a starting point. It's a core interface that point to the database. Uh, so it's a core interface to the database. Uh, for example, you can think about it's like a manager that's manage your database connections. That's basically our DB engine means. So in order to start work with database, means SQL Alchemy, you need to install a couple of packages. So first you need to select a database. I'm going to select here it's a PostgreSQL, and you can use any of the uh, databases MySQL or SQLite. Only the DB URL will be changing. Rest all the implementation will be the same. That's the beauty of SQL Alchemy. So let's get install our packages. So I'm adding um, SQL Alchemy as my first package, and I need, because I am using Postgres, I'm going to add, next I need to add PsychoPG2, which is uh, will be managing our PostgreSQL database. So I'm installed both. Now we can create a new Python file. I'm going to name as main.py. Here we are going to create our first engine. Okay, so to create an engine, we need create engine function from SQL Alchemy. So I'm installing that, importing that, SQL Alchemy, import create engine. So we are going to do an engine, create engine. Here we are going to substitute our database URL. So how do you make that database URL as? For if you're dealing with Postgres, you need to start with PostgreSQL. PostgreSQL and put double backward slash and then you need to substitute your username, and then put a colon, then you substitute your password of your database, then press @ sign, put your host and your port that database is running, and slash what is your DB. This will be the database URL that. So when you are developing, you can substitute these values directly into the code, which is not a problem. But when we are dealing with production ready application or production application, these informations are critical. So we need to get it this from an env file. So for that we can use a external package also called .env. So what .env will be doing is it will search for the .env file and get the values from there. So we can see how we can do. So I'm going to create an file called .env. So where I'm going to substitute my host, it will be localhost for now, and DB, and we need to create a DB if that is not there. So for a quick access, you can use the terminal as well for connecting to the um, database. That will be fast on your development side. So you can use a PSQL command if you need to connect with a Postgres SQL database, and you need to substitute your username and press W. It will prompt you to the password, and I'm going to create a database practice. We created the database. Now we will go for practice. This will be our database, and username will be Postgres and password admin. It's my local system, so this is my local passwords and local database. And just come to here, how we can read from the .env. First we need to import a function from .env. From .env import load.env. So just we need to call load.env. So if you call .env, it will search for the .env file in the root directory. If you need to put it in some other folder inside this working directory, you can specify the path here, .env path, a relative path, absolute path will be working from your this working directory itself, not from the actual root directory. And in order to read from there, you can import OS. So we need the username, which will be os.getEnv. This will be one method, like you can put the env name here, or you can import from os import environ. That's also the same thing it will be doing, but it has another features, that environ.get method, where we can request for a key, username, and if that is not present, we can go for a fallback scenario. It will be possible in .os also, os.get env environ, but this will be a more understandable, more because OS is a large package. We don't want those packages coming into this one. So choose your dependencies wisely. And then we need the password. So let me complete this one. Okay, so we will complete our getting part. Now we need to make the DB URL. Either you can go for a variable like this and substitute by f string. It will be, that's depends upon your code what you need to do. Either you can directly substitute there, or I'm going for this one. So in username we can substitute by whatever username we are getting. Regarding password, we can substitute the password here. Regarding host, we can substitute host here. Regarding DB, we can substitute the DB. And also, if you are connecting to a RDS database or any database in Azure, you need to substitute an SSL mode also. What SSL mode uses like is will go for an SSL authentication. Make sure that your connection is authenticated. So that value you can put it as required or disabled, depends upon your configuration in the RDS. So we can just put the DB URL here. This is how we will make a simple engine. When you are doing a project, it will be helping you this way. And if we move ahead, say if I go with this approach, what it will do is it will work for 2-3 users, that's for sure. But when we are deploying to a production application, or when we are going for a test user acceptance test scenario, there can be hundred of concurrent users. So the application will start a connection timeout error if we go with this approach. So we need a like a better approach to manage the connections. So we can, for that what we are going to use is a connection pool. That means we will say the application, the engine, what all, how many connections you can use at a time, what will be the recycling of connections. So those set of arguments we need to pass. So for that we can substitute the arguments here itself. First we will put the DB URL, then we will go for a pool size. You can see pool size. What pool size means, uh, how many connection, how many persistent connection it need to be keep. So how many persistent connection, okay, only one T, connection it need to use. That will be the pool size. So how we can calculate the pool size is by expected concurrent, okay, concurrent users divided by average request time in seconds. So this will be the pool. Okay, I will make to here. So pool size will be expected concurrent users divided by average request time in seconds. For example, you have 100 users and the average request will be 0.1 second. So average request. So it will be 100 divided by, so in this case pool size will be 100 divided by 0.1, which will be 10. So 10 connection we need to use. So I'm going for the 10 connection. Next, what is the next argument we need to do is max overflow. Okay, I need to put a comma here. Max overflow. It's an integer value. What max overflow is when all these connection. That means we say we need to persistent with the 10 connections. All this connection got hosted or got busy. How many extra connections that the application can create to the database? That will be the max overflow. So why it's important is first thing it handle traffic spike without crashing. Okay, that's why we are getting max overflow, setting the max overflow, but you won't set a max overflow in the production system. We will get into that when we are going with the production ready engine setup. So how many additional connections it can create? So why it's important? Handle traffic spikes without crashing the application. What is the next argument? What is the most important next argument is will be pull timeout. If you are not getting the don't remember the definition, just highlight this and go to the means documentation and you can see what it will be written there. So what is full timeout is how many seconds we can wait for a connection. Say if no connection is available, it will wait for how many seconds we are specifying here before giving up. So if I put 30, that means if no connection is available, it will wait for 30 seconds before giving up. That will be the full timeout. And why I am going with 30 is, okay, I will explain in the readme file. Full step. Okay. The first question we will be coming in your mind is why 30 seconds? It will be a balance between, like for me it will be a balance between user experience and system stability. So you can go with any of the like time which is specified, like what your system stability you need, and with respect to user experience it is depend upon you. And when it is too low, what happened? It will be getting users will be getting errors during busy period. Okay, I've missed an R there. So why it's getting errors? Because on 30 seconds, I means when a connection is not available, we overflowed the connection. We have 10 persistent connection, all are busy, and it not connection is available, and we just say didn't set the timeout or set the time out to 10 seconds, the user will immediately get a request. It won't wait for that long. And second is too high. Hang the so if we set to 1 minute, 2 minute, it will wait for that much time, and users won't get the response, and the system resource all will be getting exhausted. That means it will be going to consume lot of resources. And if we go again, the next argument, which is pool recycling. Pool recycle. Pool recycle means after how many seconds we need to recycle our connections. We can't set the connections to ideal, no? So we need to say recycle the connection every few seconds. So generally we can set to 3600. It will be recycle connection every hour. So it will be 16 to 16 to 60 as 3 sorry 16 to 60. It will be 3600. So that will be the after 36 seconds the connection will be refreshed. And why it's required? First thing, database close the ideal connection. DB will often close ideal connection automatically, so we don't worry about the ideal connection. Why we need to set? In PostgreSQL, it's okay, but when come to MySQL and all, the default timeout is 8 hours in database side. We can change the value, but default will be 8 hours. So but the network issues can be break the connections in between, so we need to recycle the connection. And last, when you're developing the application, set pool pre-ping to true. So what it will do is test the connection before the using them, so you don't get the errors in between. So that's why we are using the pool pre-ping. So if I explain it's a bit detail, so what it will do, test each connection before using. So scenario will be, just assume a scenario, database restarts while running the application. It can be happen, right? So without prepping, your app will be tries to use the dead connection and crash. If prepping is enabled, SQL Alchemy detects the dead connections and create a new one. So that's why we required this pool prepping. So this is how, when we are going to create a database engine when you are testing or developing the application, not for a production application. Then how we are going to create uh, a production? It will be simple. First thing, we will set the pool size. So this will be for a production engine. A production engine. So first thing, we don't set maximum overflow in the production because we can't take the risk. First thing, predictable resource usage. When you are testing, when you're developing, you will know exactly how many connection your app will be using. And second thing is easier monitoring. Connection will be the consistent, means connections will be constant, so we can just monitor, and performance improvement will be there. That means there is no overhead of creating or destroying overflow connections. And database planning. So when we are doing a DBA can allocate exact connection limit per application. So it will be help your application in a better way. So we see that when we are setting the pool size to 10, we require a 20 max overflow. So because we know that when we are going to production, what we'll be doing, we will set the pool size to 20 so that it won't, we don't require the max overflow. And we can set the max overflow so to 0 also for a better safety. And pool timeout we will go for 30. And here we can recycle, we can go for a aggressive one, say go for an 8 half 1800. This will be recycling every 30 minutes, so it will be an aggressive, which is up to you. Pool prepping will be good if you are using. And then we need to set some connection argument so that we can create connect args. Okay, we need to put a comma here. Connect args, it will be connection settings. So first one is connect time. Connect timeout will be 10. Okay, what was error? Okay, not equal to, it will be called. So it will be, do not wait forever to connect. If you have experience run fast API application, you see like it will wait more than 30 seconds or 40 seconds to connect. Sometimes wait like long. So we can set a connection timeout so that it will be automatically you know, timeout the database. Then in order to identify the connection, we can set a application name. What it will do, it will help us say this will be a sample application. For database monitoring, this connection will be named like this one, so we can easily monitor. So this will be the two connection arguments I like to put when I am developing the production application. And if we can set also echo, I forgot to mention here what echo will doing. It will be okay. I need to put a comma here. I'm forgetting that one. Echo. What echo will be doing? It will be echo the SQL statement before its execution, so that you can see what your query is. You can put here uh, that as a true if you need to see the query. And also there is also echo pool is there, but that also falls in your production application. And use it when echo pool is required, no? It to set that true if you want to debug the connection issues. Then it will be showing when we are connecting what are the SQL statements we are executing. So when we are going with series, we will execute, like we will see what is the execution of this engine. And you can set listeners also to the database, which is not required this time. We will see that as well. So this is about the creating connections only, it means engines only. So I hope you get the idea like how to create an engine in a development side and a production side, and how you need to get the variables. I hope you enjoy this video, and if you have any doubt, please comment about your doubts, and I will answer that ones. We will see you in the next video where we are going to discuss about how you can just create the model database models in using SQL Alchemy, and how you can easily create that one in the database. Okay, then we will see you in the next video. Till then, bye and have a great day.